Section 1.3 slopes. The first thing was going to identify four slopes. A positive slope, an example of that would be m equals 4, which is also the same thing as 4 over 1 since there's a known 1 there. An example of a negative slope to match that graph would be m equals negative 3 halves. Next, we look at a slope of 0. The fraction for that may be m equals 0 over 2. And a slope, an example of an undefined slope, may have a fraction that comes out to be m equals 5 over 0. Those are just basic classifications of the slopes that we will see. Next, we're going to be asked to use this given formula to find slope of a line passing through 2 points. So we take our formula, which is right here. It says slope equals y2 minus y1 over x2 minus x1, and we begin there. We're going to label our given points in the first problem x1, y1, and x2, y2. We take our formula, m equals y2 minus y1 over x2 minus x1. We're going to substitute those values in. y2 is negative 1 minus y1 is 7 over x2 is 5 minus x1 is negative 3. Now when that occurs, when you have minus and negative, we're going to add our inverse there and then continue to simplify across. Negative 1 minus 7 is negative 8. 5 plus 3 is positive 8, and then when I divide that out, negative 8 divided by 8 is 1. So we have a slope of 1. Next, we will discover how to find slope using rise over run. Most of the time this is when we're given a graph and asked to find the slope. Some directions is if it's positive, we want to go up. If it's negative, down for our rise. And then for our run, if it's positive, we want to go to the right. And if it's negative, we want to go to the left. So if I were asked to describe in number 2 how to find the slope m equals negative 2, 3, I would go down 2 and to the right 3. Down 2, right 3. To describe how I would find the slope in number 3, first I'm going to put my fraction over a known 1, and then I'm going to describe that. I would say I would go up 3, right 1. Up 3, right 1. Number 4, they ask us to give the slope of the given graph. So they're going to have a graph and they're going to have a point. So we're going to find the point at which it crosses directly, which looks about right here, and it's got to be our rise over our run. So we're looking for rise over run. So if I start at this point in blue and I say how many do I rise, how many do I go up? 1, 2, 3, 4. I go up 4. And how many do I have to go over to meet my line again at this point, which is a direct cross through, is to the left 1, 2, 3. So it's 3, but since I went to the left and we said going to the left is negative, it's 4 over negative 3, which is the same thing as negative 4/3. It's still still represents a negative slope. The next thing we're going to talk about in this section is using the slope-intercept formula. That formula is you're going to be very familiar with this formula by the end, and is most often used in a lot of the graphing, is y equals mx plus b. Your m represents your slope and your b represents your y-intercept, which can also be represented as an ordered pair 0, b. They'll ask you graph using the slope and y-intercept, and in number 5 they gave us y equals 3 halves x minus 4. So the first thing we're going to do is label my slope, and my y-intercept. So I'm going to say slope is 3 halves, and my y-intercept is going to be 0, -4. Once I have that labeled, I'm always going to start at my y-intercept, which this is my y-axis. So I'll go left or right 0, down 4, and I'm going to put a mark. Then I'm going to apply through my slope of 3 halves. So I'm going to rise over 1. So I'm going to go rise 3, 1, 2, from my given point, 1, 2, 3, and then to the right 2. Put a dot. Rise 3, 1, 2, 3, to the right 2, 1, 2. Put a dot. So I'm showing that I'm rising 3 and I'm running 2 each time. Rise 3, run 2, rise 3, run 2. And once you get that established, at least 2 good marks, then we can take that and draw a line through them to graph the given slope. Those are the basic forms of slope and some of the questions that they'll be asked. Next is a few of our special cases. In this case, anytime you have an equation that says x equals some number, it's always going to be a vertical line. For example, the graph of x equals 3 is going to be graphed, let me get a line, it's going to be graphed at x equals 1, 2, 3, and it's going to look like this. Y equals, on the other hand, is always horizontal, so the example of a graph of y equals -3 is going to be a horizontal line in that manner. So these are our special cases for slopes, and those are most best memorized. You'll be better off if you memorize those 2 special cases. And those are all the general forms and the way in which we're going to use slope in this section.